All right, so thanks to Sam for that presentation. I watched you go through earlier and just learned so much more about regex and playground. All right, so thanks to Sam for that presentation. I watched him go through it earlier and just learning so much more about regex. I played around with it and it was a big scary thing, so it's great to be a little bit more informed on how that all works. If any of you guys can't hear me, wave, speak up, whatever, let me know. But I'm going to talk about machine learning with ML.NET, a little bit of background on myself. I'm a software developer, obviously, been at Buildertrend for 4 years now. I'm a team lead on the Code Health team currently, so this is not something that I'm an expert on by any means. I don't do data sciences or machine learning for a living. This is something that I've just kind of started digging into in my free time. There's going to be some math and statistics things that come up that I quite frankly can't really speak to. We do have two people who are kind of data scientists right here that might be able to answer questions, not to put you guys on the spot, but yeah, just it's something that I found is pretty neat to deal with. So to quote Sam Kirkland here, when faced with a tough problem, make somebody else do the work, I live by this rule, Sam Kirkland. In hindsight, I kind of wish that I had just built a demo of seeing if we could use ML to detect what is and isn't a valid email and see if it could beat the regex. So maybe that's something we'll try a little bit later. So yeah, so let me talk a little bit about ML.NET. It was announced at Build 2018. This is a port of what Microsoft has been using internally for SQL, Azure. Azure has their machine learning pipeline. I think they utilize that, but also just for business insights and analytics. Windows, and then the thing that may make you think, okay, maybe this isn't such a great tool, is they use it for Bing too. But yeah, I mean, overall, it seems pretty good. So it is cross-platform and open source. So their goal, and I will clarify up front, they're not quite at this goal. They have a long ways to go in several different areas, and I will repeat that throughout. But their goal is to make machine learning, or ML as I may refer to it, accessible for .NET developers, specifically without prior knowledge or expertise in developing and tuning machine learning models. It is currently at a 0.3 release. It is a long ways from a 1.0. 0.4 is on the way, and it sounds like there's going to be some major API changes coming with that, so understand that everything I'm talking about here is pretty fluid. I watched their announcement video, and back then they actually had even better debugging tools than they have now, so they've almost taken a step back in certain ways. I'm sure it's for performance, and I'm sure there's a legitimate reason for it, but things are very fluid and changing quite frequently. If you want to get involved, go to github.com/.net/machine learning, and then for a list of samples, same thing with a -samples at the end. So kind of going into what this process looks like. So you start with a training pipeline. So a training pipeline consists of input data, transformations that you're running on that data, feature concatenation, which is a type of transformation, actually training the learner, then mapping or defining the learner, then defining any data mapping from what that learner spits out, and then the actual training takes place. So you define your pipeline, and then you actually call .train on that pipeline. What that does, so one of the issues here, so in their demo video they showed at Build, they actually had the ability to step in and see the data after it's loaded. Then when you apply one transformation, and I'll get into transformations in a bit here, you could actually immediately go to the debug window and see the output of those, see what the current status of the data set is after you applied a transformation. They wait now to apply the transformation until you actually call .train. That makes it a little bit more difficult for catching exceptions. Exceptions all happen when you call .train, so you don't necessarily what it is that's in the wrong format, what blew up, that type of thing. So I just kind of wanted to get that out of the way. It is moderately difficult to use in the current state. So what are transformations? Transformations are really taking the data that's in one form and converting it to another form. You can do this by adding additional columns to your current data set, or just doing in-place transformations where you iterate over every data row. Essentially, I'm not going to get into their input data view. There's an entire readme.md on their within the repo that talks about that. You can go really in depth. But really, transformations convert from one column type into another. And again, that can be done in place. So you can just iterate over all the rows, convert text to n-grams, and just iterate over, or you can spin it off into a new column. There's a bunch of standard types in the data view, but you can also use any strongly typed classes as well, as long as you have a decent way to convert that. But their standard types are text, dates, all kinds of numbers. There's floats, signed ints, unsigned ints, signed longs, unsigned longs, all of those things. Vectors, which I'll get into a little bit later, and keys. So keys are for taking essentially numeric values, something like a social security number, a phone number, a database ID, where the magnitude of the number doesn't actually have any level of significance at all. Someone's social security number could start with 502, someone's could start with 413. That actually means nothing at all. It's just a way to, we use numbers to represent that. So that's what keys are for. So just kind of to show what this is doing, I took this from the presentation that they gave at Build. They have this, we'll get into a dictionaryzer, a text featurizer, but a text featurizer is a type of transformation. So what you can see here is it's iterating over the rows, and it's taking this title, which was something like this, and converting it to something like this. So it's a vector it's a vector made up of floating point values. That's done, again, using some data science things called n-grams. The best way that I can think of that I understand n-grams is you can have like a 3-word n-gram or a 3-character n-gram. And what that does is it starts at the front of a sentence. Is my mouse showing up there? Yep. You can start at the front of, I guess, a block of text. And if it's a 3-word n-gram or a trigram, I think it's called, you would take convert data from, group that, and essentially count the number of occurrences that those 3 words appear in that order. Then you move to the next word, data from 1. Group that, add a value to that, and figure out how often that appears. So that's kind of what these vectors represent. So there's a total of n-grams that exist, and it shows the frequency and turns those into floating point numbers. Then there's other transformations you can use. So there's the categorical one-hot vectorizer. What this one does, so this is for things that are more unique. So let's say you have a list of statuses that are texts or people. People may be a good example. So we have, a few people. Actually, you know what? Let's use the example from the form that I found online. So you're going through and you're categorizing these entities, these living entities, as being a human, a penguin, an octopus, or an alien. So what it does is it creates, this vector is n wide for the total number of values that you have, and exactly one of the values in here will have a 1 in it. It can't be a human and a penguin. It can't be a human and an octopus. It's one or the other. It's one and none of the others. So exactly one of those has a 1 in it. So that's what a categorical one-hot vectorizer does. Is it essentially generates a vector of 1s and 0s where exactly one value is a 1. A text featurizer uses n-grams as well, word n-grams and character n-grams. Character n-grams work the exact same way as word n-grams, where it just iterates through the values based on how many characters you want to cover. And then you use a column concatenator. So what this does is it takes columns that are all of the same type and converts them into one big vector column. So that's usually what you do to get your feature column. You can use it for other reasons as well. But every single trainer, and I'll get to trainers in a minute, but every single trainer requires a feature column. It trains on exactly one column called features. You can give it any name you want, but the default name is features. So you have to concatenate all of your different columns that are in the state that you want them to be into the feature column. Another one that we use is dictionaryzer. Dictionaryzers are for essentially generating a dictionary of valid terms. So statuses may be a good example of that when you're trying to label it. So the example that I'm going to show you, I'll get to that later actually, sorry. But it essentially takes those valid values and just assigns an integer value to it so that when I'm looking up a person, let's say I'm looking up Sam, Sam's a value of 5, it goes ahead and creates that value of 5. So actually back here we can see system.net is the area here. That's what they're dictionarizing up here. Area, they're converting it to label. So area-system.net has a label of 5. So it just converts that to a numeric value. It's a key to look it up by in the future. And then there's tons more. These are just the basic ones that I've used. There's a lot more out there with very little documentation. So that's kind of going to be a repeating theme. They're in 0.3. They have a long ways to go documentation-wise to actually get this ready for a 1.0. It's something that if their goal is for non-math folks to be able to use it, they're gonna have to step up their documentation. So now let's get into trainers. So what trainers are? This is the real piece that's analyzing your data that you're passing in and deciding what to do with it. So you have binary trainers, which are essentially just taking something in. Let's look at the email example. I would pass in known values with this training data, and I would say either this is an email or this is not an email. So it has a yes or a no that it's evaluating to. Another really good example that Microsoft's used a lot in their talks about this is sentiment analysis. There's tons of sentiment analysis engines online that you can utilize to determine whether something's positive or negative. But the example that they use, which I think is a pretty good one, is a vacuum cleaner company. If someone says these vacuums really suck dirt, and you just pass that through to a standard sentiment analyzer, they're going to assume that that's a very, very negative sentence. Where in the vacuum industry, that's actually a huge compliment. So there's really kind of the goal of this is domain-specific data so that you can train your own. Granted, this takes, and I'll get to it later, but this takes gathering a lot of training data to be available for you to use. Another type of trainer is regression. So regression is when you take known numeric values and you're trying to predict another numeric value, such as the cost of the materials needed for a given purchase order or for a house that you're building based on zip code, based on time of year, that type of thing. There's also classification. So that can be something like automatically labeling issues in a ticketing system or trying to automatically determine which subcontractor a given purchase order will be assigned to based on contents of it. And then there's clustering and anomaly detection, which are a lot more interesting because they get into unsupervised learning. So unsupervised learning is where you kind of just give it the data and say, go ahead and see what you can come up with in terms of finding groups that are similar. So let's say you added in, let's say you've had subcontractors in your system and you haven't had the ability to categorize them for forever, and you want to just see, can we automatically categorize these for our users? Well, you could pass all the subcontractors through and say, come up with a total of 30 different divisions for these subs and just see what it spits out. This is something that I tried with one of our builders' data. They had 169 total subs. I asked it to spit out 30 different groupings. And unfortunately, we weren't able to really find any sort of accurate categorization. I need to dig a little bit further into where it's coming up with the categories and groupings that it's doing. But it's hard to find the right data and know what's important for this model to understand. And then there's also anomaly detection. So just trying to find outliers in your data set, trying to see what's wrong in this. So then after you actually train your trainer, there's an evaluator. So when you train, you use training data. Let's say, let's stick with the ticketing system example because that's what I'm going to be using as a demonstration. You have 100,000 issues on GitHub or 100,000 tickets in your within your ticketing system, and you want to you have known values of the type of this, the category of this, that type of thing. Well, what you can do is pass all 100,000 of those through and train on it. But then what you want to also do is verify that the data that you're passing through is valid. So you should leave out, let's say, 5,000 of the 100,000 records that you can verify on. One big thing to kind of keep in mind here is when verifying, you should probably verify on newer data because you're training on older data. And if you've had process changes, things like that change up the what you're doing, you want to make sure that it's accurate on new data, not like go back and train on the newest data and then verify the old data. So these trainers, there's one for every type. So for regressors, for binary classifiers, for category classifiers, there are evaluators that can go through and you pass in then those 5,000 tickets and see what it spits out. You know the answer to it. You don't tell the algorithm the answer to it, and then it tells you, hey, here's what % of these I had right, here's what % I had wrong, and does all kinds of statistical analysis on it to figure out whether you're on track with this model or whether you maybe need to change up which trainer you're using. So going back to trainers, these binary ones, if you look, I think there's probably 20 or 30 binary trainers currently available. And I'm assuming all of those were created by someone who wrote like their PhD thesis on binary training, you know, really in-depth analysis going into this. So some are better than others in different situations. So let's go ahead and just jump into a demo here. So we have our ticketing system up here, BT Project. So I've already created the model and generated it. And I should probably actually show you what that step looks like. Is it hard to see? Is it? Oh man. Shoot. Is there an easy way to swap over to a light theme? Perfect. Can you guys see? All right. Thank you. I have literally never used the light theme, so this is kind of foreign to me here. Visual Studio 2010. So what we're doing here is we are going through, and I guess let me sort of show you the model. These are essentially the pieces of information that we pulled in from our system. It's really just, we know what the value is, so this predictive label is our known value right now, the title of the ticket, the description of the ticket, and who created the ticket. So first we create the learning pipeline, which is by calling new learning pipeline. Then we have to go ahead and load in our data. This can come from anywhere. This can come from a CSV file. This can come from a list. This data collection data source.create takes in an iList. So you can just pass through a list of entities. I found that the easiest. That way we could pull it from our database. I didn't have to generate a CSV or anything. But you can get your data in any number of ways. So this is our training data. So what I train this on is tickets 75,000 through 85,000. We have a total of like 90,000 on my local host issues, and it was just taking a really long time to train it, so I figured 10,000 was good enough. And then what you do, so we have this dictionarizer, like I kind of talked about, that takes all of these labels and converts it to just a numeric value representing that. Then we have these text featurizers, which is going through and generating these n-grams. So what I'm doing here is I'm saying, create this new text featurizer, and the old column name is title, the new column name is title, so I'm just doing an in-place replacement of the title with the vectorized float data. So I guess one thing I forgot to mention is most of these trainers, most of these learners want the data to be in float value. That's what it deals with best is floats. So that's what n-grams do for you. That's what these categorical one-hot vectorizers do for you. That's what dictionarizers do for you, is they give you a float value that it operates on. Figuring out which thing to use is not easy, and I'm not gonna be able to offer any advice on what to use there beyond, you know, the basic. Here I'm using a categorical one-hot vectorizer because this isn't like a massive number of data sets. This is kind of a fixed number of data points, so it's kind of converting these to keys. Text featurizer seems to do a really good job of generating floats from the features of the text, which is what it's supposed to do. So then what we have here also is this column concatenator. So I told you that we need to take all of these and combine them into one vector that we end up passing in called features. So all we're doing is we're calling this column concatenator on title, description, and the issue created user ID. So then we call the good old stochastic dual coordinate ascent classifier, which is the particular classifier that I'm using here. There's also, so I mentioned that binary and regression classifiers have, there's quite a few out there. What there's not a lot out there of is these just like label classifiers trying to label items. What they do have is what's called a one versus all classifier. So for that, you essentially use any binary classifier, then it runs through and generates a binary model to say, is this feature a bug? Is this feature an enhancement? Is this feature, this type? And it generates a binary classifier for every single one of those. And then it runs the classification against all of those and sees which one gets the highest score and which one it's most likely to be. So then this last piece here is this predicted label column original value converter. So all that does is, remember up here we created this dictionarizer. That takes it and kicks it back out and says, okay, the value is 5. Okay, that means it was a bug. So it just spits it back out into the same value that you originally had based on that dictionary mapping it created. So then the last step here is you call .train, which goes through and takes those 10,000 issues, runs all the transformations on it, and then does its learning. When you create this classifier, you actually have the ability to specify things like number of iterations, number of threads, max iterations to do. It'll try to optimize it based on the size of the data set, performance, things like that, so that it doesn't take too long of time. What I tried to see if it would increase our accuracy is bumping it up to like 10,000 iterations. By default, it was picking like 400. But what I found is that it was settling on like the 78th iteration. So those extra ones, at least on our data set, weren't actually doing that much. Again, I'm assuming that varies from data set to data set heavily. But yeah, so it does its best to figure out how to optimize that, and then it spits it back out. Now, what you can also do is it writes it to this model path, so you can say where to save this. It generates a zip file, and I can show you this, what's in that zip file right here is just this data loader model, all of these different transformations that are run on it. You can peek into some of these. So here's the title word extractor n-grams, just the one that I picked at random. So this is all of the single words that exist in, I actually had that open already, but this is all the single words that exist in these, within the titles of all of these tickets. So you can scroll through and kind of see that. It's the ID of it and the name of it. So it can load that up from, from that so that we don't have to retrain it each time. This takes about 5 to 10 minutes to train. So instead, we're just loading it up from the file. So I'm going to go ahead and build. I will have to retrain it just to reload it from the file. Any questions while we're waiting for this to build? Okay.
You said it took like 5 to 10 minutes to train.
Yep.
You bumped it up to 10,000.
This one was on 10,000. So I've been tweaking this a lot, and I got impatient and didn't want to sit there through 90,000. So I just bumped it down to 10,000. So this took, and I'm training 2 different trainers or 2 different models. So.
How large did you make it again? I'm sorry.
10,000. Yeah. We have a total of. Yeah, we have a total of 90,000 we could use, but for speed, I did 10,000. So can someone just, I trained on ticket numbers 75,000 to 85,000. Can someone just throw out random numbers between, say, 30,000 and 90,000? What? Okay. So what I have here, so this is a known thing where I'm not going to go through and create a ticket for you and let you watch me do that. But what I'm going to do is just pick some random ones. So I added this, this predict button. And what this does is this is only sending up the title, the description, which is not very in-depth, and the ID of the user who created it. So that's the only thing that I'm including here. If you really want me to show you the network call, I can. But what I'm doing is I'm see this category field, which has about, I think it's 25 types, and then this type field, which has about 15. And it will turn red if it's not predicted in the top 3. It'll turn green if it's actually the one that it predicted, and it'll turn yellow if it said this is either the 2nd or 3rd most likely item. So we predict it. So it knew that the category was videos. It was incorrect on the type. We could dig into what that thought, but I mean, I can try this with several other ones. I mean, I'm just picking numbers. If you guys don't believe me, you can shout things out. What? Yeah, this is our ticketing system. It's a fork from a thing called BugNet. But yeah, this particular part with the predict and outlining this, yeah, I added that. But I'm pretty sure this is a sample one that I used earlier. Look at it should have been QuickBooks, but it guessed time clock. This is the same one. I'm picking random numbers. Anyone have another random number? 65,000? What? Okay. So as you can see, it's not always accurate. When I've been doing this, we've been having some pretty good luck with getting a lot of green and a lot of yellow. I've been tweaking this so much before the presentation, I haven't actually run this with our current iteration of the model, but I can tell you that when I first started doing this, we were accurately predicting category. This is before I was trying to suggest the top 3 most likely ones. We were accurately predicting category 75% of the time and type like 68% of the time, somewhere around there. So if we filter that down and say, you know what, let's only show the top 3 most likely suggestions first, it eliminates just as you're putting in tickets, you know, having to scroll through, find the right one when we bring up first and say, hey, here's where you should start with this. So. To be honest, that's where we've had the most success. So I'm going to kind of talk about, you know, where we've had successes and where our learning opportunities are. We tried to go through this and think, how can we utilize this within the Builder Trend application? You know, something to actually provide value to our clients. This is an internal tool. We're the ones who are using this, and yes, it'll save some time. But we wanted to really dig into how can this provide data to our clients. It was hard to come up with anything that had a high degree of accuracy, high enough that we'd be willing to actually get the data out there and start predicting and making decisions for them. And I think there's a lot of facets to this. Just my lack of expertise and knowledge in understanding what these are and the lack of documentation on Microsoft's end to try to teach these things has definitely been a pain point. Another piece of this is that we don't force our users, our builders, to enter data in a specified format. Obviously, we have columns that they're using. We give all these same features to all the users, but they're not all using all of the features. We don't have every field as a required field, that type of thing. And then we also, you know, when I talked about automatically predicting which subcontractor should be on a purchase order, well, you're not going to suggest that some builder from Florida subcontractor be used on you know, a builder from Nebraska. That wouldn't make much sense. So we were segmenting it off on a builder by builder basis, which meant you have to have a very large amount of training data available to make that work. So finding data where we had enough that was in a standardized format was really difficult. So those are the main hurdles we ran into, and we're definitely not going to give up, mainly because this the accuracy for our internal tool was really neat. And if we could provide that to our users, it would be of huge value. So we're going to keep looking for different opportunities there. One thing I do have is we projected, we looked at schedule items, and this is, this builder had 26,000, let's see, 26,617 schedule items that we tried to project the length of. Of those 26,000, we accurately projected the length of 7,000 of them, and we were off by 1 day on 10,000 of them. So that says we were at an off by 1 error or spot on about 66%, give or take. So this here is what's called a confusion matrix, where you're essentially looking at what we predicted versus what the actual value was. And this green diagonal is where what we predicted was the actual value. There's a lot more red around there, but that's just because there's a lot of red columns. What we care more about is the magnitude of these columns, the value within them. It's a lot to dig into, and I haven't really taken time to process all of it yet. The yellow is when you add 2 days. Something was wrong in our training model because it was predicting that schedule items would take 0 through -5 days. I don't know how you could have a time frame that's negative. So there's something weird with the data that we're piping in, essentially, is what that means. We're doing something wrong in piping in the data in a format that it can't figure out. So it's been interesting to dig into it and learn it. I'm not going to sit here and say it's a silver bullet, but maybe for email address detection, maybe that's the way to go. So what's next? as I said 3 or 4 times now, hopefully better docs are coming. If their goal is for us to be able to use this, they need to increase the documentation on it. They are going to, it sounds like, be adding a UI for building models where you could upload your CSV or just add it, map out the different fields and say what type of transformations you want to run on it. Then it'll actually generate that code for that pipeline for you. It would automatically generate this based on a UI for building this. Another thing that's going to be really cool, I saw a GitHub issue where someone was asking, essentially, the model that our algorithm generated is actually more accurate at doing what it's doing than our people are. Can we visualize why it came to the conclusions it came to and pump in a feature and say, how did it come up with this? The response was that on their internal repo, I said it's being used for Bing, Windows, Azure, SQL. They said they currently have that on their internal repo and they're trying to determine when and how to bring that over to the open source repo. But I think that's something that could be really cool to figure out what can we learn from the mistakes that we're making where it's actually more accurate than we are. And then the last step is actually x86 support. It is currently this only works on 64-bit applications. I actually had to convert BT projects over to 64-bit in order for this demo to work. So that's something that if they can't expand that support, they're going to kind of limit the adoption of it. So that's all I have. Any questions out there? Yeah.
How do you set it up? I mean, does it come with its own SDK?
How do you set this up? It's a NuGet package. So it's just Microsoft.ml, I believe it's called. So yep, NuGet package. Yeah. Anything else? Yes. I don't know. I know they're looking at expanding hardware intrinsics. .NET Core can utilize hardware intrinsics, I think it's called. So they're looking at utilizing that for the math operations, that type of thing. I don't think they're there yet, though, with GPU acceleration. Yeah. What was that? I don't know. I don't know if it's something that makes sense to. I don't know whether you just their unit tests that are testing their trainers, they actually have known inputs and outputs, but I would assume that that's all hardware based, right? So that's based on if you're on a faster computer, it's going to run more iterations, it's going to tweak things differently. So I don't know the answer to that question. Yep. Yeah. Yeah.
If I were building a tool from scratch and I want to do a lot of predictive fields, is that too early to realize that, or do we need a lot more data?
I think you need data. So there's actually tons of resources out there. So one example that Microsoft gave in their talk is the US Department of Transportation keeps track of flight statuses of like every flight, and it's a downloadable CSV format to figure out whether the flight was delayed, what day it happened, what airline it was, where it was to, where it was from. There's like 90 different columns you can select. So if you're building something like that or taxi fare prediction, there's massive amounts of open data out there that you could use. But if you're doing something internally where you don't have an open data source, there's not much you can do there.
So you could make data, you could kind of fake data at the beginning too, like depending on how the scale, to kind of force the initial predictions, or would that maybe?
I don't know if faking data for machine learning is
That would mess
a
with
good
your
approach.
predictions.
Yeah.
If you fake data, it learns to predict how you think. So it'll predict your rates.
So I can drive my customers.
It's going to predict what you're doing.
Right. Right. So a good example of that is sentiment analysis. So if you're doing your own custom sentiment analysis, you're going to have someone go through. So one example of where you'd use that is posts on social media. If someone tweets at you or someone comments on your Facebook wall, writes on your Facebook wall, determining, hey, do we need to escalate this to a support person really quickly because they're upset? Well, what you would do is you would actually have someone go through and load in all of your previous posts and say, yes, this is positive, or no, this is negative. So to fake that, you would have to like come up with a bunch of really mean things to say and a bunch of really nice things to say and train it on that. And I'm not sure that that would be effective. So, any other questions?
Is the performance good enough for real time, or is it better to just post analysis?
For training, definitely not real time. You want to create that file. But in terms of the prediction, from what I've seen, it's good. I don't know if you could make thousands a second, but you could. You want to train ahead of time. You want that to be a nightly batch or a monthly batch or whatever that is to train it. But predictions, once you have the model trained, is pretty quick. So, is that it? All right, thanks, guys.